Alright everyone, let's tackle a really interesting problem today. We're given that 2x plus y equals 2. Our goal to find the minimum value of the square root of the quantity x squared plus y squared. Think you can solve it? There are two cool ways to approach this. One uses the Cauchy-Schwarz inequality, and the other uses a graphical or coordinate geometry method. Let's try Cauchy-Schwarz first. Recall the Cauchy-Schwarz inequality. We can think of A as x, B as y, C as 2, and D as 1. Plugging our values into the inequality we get the quantity x squared plus y squared, multiplied by the quantity 2 squared plus 1 squared, is greater than or equal to the square of the quantity 2x plus y. Since we know 2x plus y equals 2, we substitute that in, simplifying everything. We find that x squared plus y squared is greater than or equal to 4/5. Taking the square root of both sides, the square root of x squared plus y squared is greater than or equal to 2 times the square root of 5, all over 5. Remember, equality in the Cauchy-Schwarz inequality holds. When A times D equals B times C, that translates to x equals 2y, and that is exactly when we achieve our minimum value of 2 times the square root of 5 over 5. Now, let's look at the second method. Picture a coordinate plane. Our equation, 2x plus y equals 2, can be rewritten as y equals negative 2x plus 2. Its graph is a straight line, crossing the axes at point A, 1, 0, and point B, 0, 2. Look back at our target expression, the square root of the quantity x minus 0 squared plus y minus 0 squared. Recognize that? That is just the distance from any point xy on the line to the origin 0, 0, so we need the shortest distance from the origin to any point P on the line A. The shortest distance is always the perpendicular distance from the origin to the line. How do we find that length? We can use the area formula for triangle OAB. The area is 1/2 times OA times OB. OA is 1 unit. OB is 2 units, so the area equals 1/2 times 1 times 2, which equals 1. We can also find the length of AB itself. Using the Pythagorean theorem, from A to B is the square root of the quantity 1 squared plus 2 squared, which equals the square root of 5. Now, the area of triangle OAB is also equal to 1/2 times AB times our perpendicular distance. Let's call it D. So we have 1/2 times the square root of 5 times D equals 1. Solving for D, D equals 2 divided by the square root of 5. Rationalizing this gives us 2 times the square root of 5, all over 5, the same minimum we found before. So, which method did you find simpler or more intuitive? The inequality or the geometry? Let me know your thoughts down in the comments. If you enjoyed seeing 2 different paths to the solution, give this video a thumbs up and share it with someone else learning math. Thanks for watching.